What I have here is a little example that I usually test students with after we've done a bit of this. And what it is to draw a one-point box, a box in one-point perspective. And in this case, we're going to use 1 inch equals 1 foot for scale. The box is 1 foot times 2 feet times 3 feet. It's seen from an eye level of 4 feet and from a distance of 10 feet away. So let's start by drawing a horizon line. And I know since the eye level is 4 feet up and the box is 1 by 2 by 3, that box will not come above the horizon. So I can safely draw this horizon fairly high up on the image area. So let's draw the horizon line and then locate a triangle here. Locate the distance line can be placed arbitrarily wherever I want to put it. So I think I'll put it here. The reason why I'm putting it a little bit to the right, I think I know I'm going to use my measuring point over here to the left, so I'm cheating it just a little bit to the right here. This is a one-point perspective. Line number 1 was the horizon line. Line 2, the way I'm doing this, will be the distance line. I'm putting an arrow that shows the direction of the line. I'm putting a number on here that indicates its sequence, and then I'm putting DL, which means distance line. Now, in one-point perspective, we know that the vanishing point is the center of vision. So I'm putting both of those abbreviations there. All right, how do I know where the ground line is? Well, using the scale, I know that the horizon is 4 feet up. That is, it's 4 inches above the ground. So in order to find the ground, I measured down 4 inches from the horizon. 1, 2, 3, 4. Here then is the level of the ground line. I found the ground line by looking at how high the eye level was. Then I measured, using the scale we're using, the distance down to the ground. So this then is step 3, which is the ground line. Now to locate the station point, I know that the view distance that I gave here was 10 inches. That's measured from the center of vision vanishing points. Again, it actually represents a line coming out in perspective like this, straight to our eye. But again, because we can't draw in the air, what I do then is fold that line down and draw it on the paper 10 units down. This is using the scale of 1 inch equals 1 foot. This is the station point. This is step 4, and it's 10 inches. Or let's use 10 feet, meaning 10 inches in scale here. So we have then this 10-foot station point. Now, by drawing from there a 45-degree angle up to the horizon, I can find the measuring point by drawing a 45-degree angle up to the horizon from here. Gives me the measuring point. Now, the easy way might be, in this case, to just know that a 45-degree angle has 2 equal sides. If you don't have a 45-degree triangle, all you need to do is measure this distance and measure it over here, and that will give you the measuring point. Now remember that definition we said. A measuring point is a point on the horizon, the same distance from the vanishing point that the station point is from the vanishing point. So in a way, in doing this, you may not even need to find the station point. If you could just start here and just measure 10 inches out, you've got the measuring point. But we want you to understand the theory, so we've gone ahead and drawn all this other stuff in here too. But know then that this is 45 degrees and that this side is equal to this. The 2 sides of a 45-degree triangle are equal. Now I'm going to draw the front surface of this box. It can be drawn anywhere along the ground line that I want to put it. It doesn't have to touch that distance line. So let's say I'm going to make it here, and I'm going to make it 2 feet wide right here. I'm measuring 2 feet, and I think I'll make it only 1 foot tall. So drawing the front surface of this, I come up to 1 foot, and I'm drawing the better triangle here. Drawing the two sides of this front surface of this box. I'm drawing a vertical here and a vertical here. This gives me a 1 foot by 2 foot object. So I call that step 6. Just drawing that front surface I call step 6. Step 7, I like to, oh, by the way, I should have numbered this 45-degree angle was line 5, excuse me. Now I'm going to draw step 7 by drawing from all 4 corners of this front surface to the vanishing point, and I'm going to call all of these lines step 7. What they are is lines that are parallel to each other but not parallel to the picture plane, therefore they converge to the vanishing point. So those lines are all step 7, okay? And I'm putting arrows indicating their direction. Now step 8 will measure the depth of this. And it's going to be 3 feet wide, so I'm going to start 0, 1, 2, and 3. Number 3 would be about right here. Now drawing from 3 to the measuring point like this will give me the depth of this object. What I'm doing here is I'm using this 3 feet to measure 3 feet here. This is equal to this. Once again, it's a 45-degree triangle laid down flat. So I'm using this 3-foot line to measure this 3-foot line here. Now what I'm doing is going up to that point that I found and making there a horizontal line. By the way, this last line I made that gave the measurement was step 8. Step 9 will be to draw the back surface of this object. So here then I'm drawing the verticals that represent the side of the back face, and then a line across here gives me. So there is a box 2 feet wide, 1 foot high, and 3 feet deep. Notice that in order to get 3 feet here, I can't measure from here. I have to come all the way over to 3. Now it's important that when you draw this, you draw back to the line you started the measurement on. So I started the measurement here, 0, 1, 2, 3, and then I'm drawing toward the measuring point till I come to the line I started on. If I draw to here, that is not 3 feet. That would only be 1 foot, see? 1 foot coming back to here. So now I have drawn a box 1 by 2 by 3 feet seen from an eye level of 4 feet. See, I came down to the ground 4 units. Then I measured it from a distance of 10 feet, comes down here. 10 inches is equal to 10 feet. 45-degree angle up gave me the measuring point. That was step 5. Step 6, I selected where I want to put the front of the box. Wherever I want to put it along the ground line. I can put it over here, here, anywhere I want to put it. If you get too far away from the center of vision, you're going to get too much distortion. So you'd like to stay in here within reason, within close enough to the center of vision to get an undistorted image. So step 6 was to draw the front surface. Step 7, I drew lines from all 4 corners to the vanishing point. Step 8 then, I measured this line right here by measuring this way, 1, 2, 3, and drawing from the 3 to the measuring point till it touched this line. That gave me 3 feet of depth. Then at that point I did step 9, which is to draw the back surface. So in 9 steps I have that. Let's see what else. What I've just done then is to do a 1-point box, which I usually use for a test that I'm doing in the class that I teach. I'm going to show here this next thing, repeating rectangles 3 different ways. So the thing about a rectangle, it's different than a square in that a rectangle doesn't have all equal sides. So let's see how that works. I'm going to repeat rectangles 3 different ways. Here then is the horizon line, and here is a rectangle. Again, I've arbitrarily decided that the depth of this rectangle is not equal to the width, and therefore this is not a square. This is a rectangle. I know it looks like what you might do when you draw a square, but it's being seen from a depth that is no longer making it a square. It's being seen from a depth where the two sides are not equal, and it is therefore a rectangle. So here is the center of vision, vanishing point, and I'm going to find the next rectangle by repeating it, by drawing through from corner to corner, from one corner to the other, up to the horizon. This gives me a reference point. Now, using that reference point, I'm going to find another rectangle. It's not a measuring point. I know it looks like a measuring point, but it is not. Now I'm finding the second rectangle here. Now what I did was I used this side to measure this side here. Now I'm going to measure another one, starting here, the blue, drawing again to that reference point. I'm finding another rectangle this deep. So how is it different from the squares? Well, if I were to draw the two sides of this coming up like this, let's get some of this other stuff out of the way that we no longer need here, and then draw this other side, knowing that this is not equal in width and depth. So let's say here is the first rectangle. What I'm doing is I'm drawing lines from corner to corner like this. Let's carry this line on up and carry this line on up. What I'm doing is I'm drawing a line from this corner parallel to this line here like this, and this gives me the next rectangle right here. So what I've done then is this red right here. Remember I used this red down here, and I've repeated it by making these parallel lines. Now it's not a square because you see this is not a 45-degree triangle. In order for it to use this side to measure this side, I have to use a 45-degree triangle. So what I've done here is I've used this side here to measure this side. And I did it again in blue, which I don't think we have room to get in here. Let's just stop it there. Okay, so that is one way of repeating rectangles, by using a reference point on the horizon. Another way is like we showed when we did the situation where we had boxes. We're repeating boxes. Let's do that again here. Let's pick a horizon. There's not too many drawings going on here. Let's pick a horizon here and then draw the front line of a rectangle here. Line to the vanishing point like this. This is a second way of repeating rectangles. Like this. Now since it's one point, all I have to do is measure this back half here, find its midpoint, like we did on the boxes, draw toward the vanishing point, and then draw from this corner through that halfway point till I get up here and get a repeat like this. Now I just keep doing this. Drawing from this corner through the halfway point, I can get another repeat. So using the halfway is a good way to do this too. So there's the second way. Now the third way, I'm going to show it in two-point perspective. So let me clear a way where we can do that. This is repeating rectangles three ways. The third way will be in a two-point situation. So let's use a horizon line. Two-point rectangle here. Now remember, when we did the one-point rectangle, we were able to measure the back half of that first rectangle and just find its halfway point. In two-point, we can't do that because, as you know, there's foreshortening in two-point perspective in both directions, to the left and right vanishing point. That means one half of that rectangle will be visually bigger than the other. One way we can do that, though, is to draw diagonal lines from corner to corner inside this rectangle and find its center. And whoops, that line didn't go all the way. Let's draw from that center to the vanishing point like this. This then divides this into a perspective halfway point. Now I know the vanishing points are close, so it's a little distorted, but I think we can live with it. Let's draw from this corner through the halfway point to get the next rectangle, which would be right here. Draw from the vanishing point this way. Here's the next one. Let's get another one from this corner through the halfway point. And draw from the vanishing point here. Do another one, this corner through the halfway point. Gives another one. So I've repeated three rectangles. You see 1, 2, 3, actually 4. Well, repeated it 3 times. So what I need to maybe notice is the location. If I were to follow these on out, what I probably will get as a way of checking this is just by going to a common point here like that. Anyway, so there I've repeated rectangles the third way, which is a 2-point perspective. All right, I want to do one more thing that's a little bit complex here, and that is I want to draw something I want to draw a 10-foot cubic room which has a 10-foot cubic room. I'm trying to find my, oh, there it is, my scale. And I'm going to do it by specific locations of things. So I have some instructions here that I use for this.